compute the critical value z sub alpha over 2 that corresponds to a 95% confidence interval. The notation z sub alpha over 2 means the z-score such that the area in the right tail is alpha over 2. In order to find this value, let's draw a sketch. We have the normal curve here. So we want to find the z-score such that the area in the right tail is alpha over 2. So the area to the right is alpha over 2, and the critical value, or the z-score, is z sub alpha over 2. We want to find the critical value that corresponds to a 95% confidence interval. We denote a confidence interval as 1 minus alpha times 100%. And because we want to compute the critical value that corresponds to a 95% confidence interval, we set this equal to 95%. And now we can find alpha. We need to solve the equation for alpha. First, we divide both sides by 100%. The 100% over 100% reduced to 1, so we can go ahead and cancel the 100%. So on the left side, we have 1 minus alpha, and on the right side, we have 0.95. Let's get alpha by itself on one side. We can get rid of the 1 in front of minus alpha by subtracting 1. And if we subtract 1 from the left, we also have to subtract 1 from the right. On the left side, 1 and minus 1 cancel because they add up to 0. So we are left with negative alpha on the left side. And 0.95 minus 1 is negative 0.05, so we have negative 0.05 on the right side. Remember that we're trying to find alpha over 2. So first we need to find alpha. We have negative alpha here, which is not what we want. So in order to get rid of that negative, we can go ahead and divide by negative 1 on both sides. So we end up with alpha equals 0.05. Now that we have alpha, we can find alpha over 2, which is going to be the area in the right tail. Since we have alpha, we can just go ahead and divide both sides by 2 and get alpha over 2. So we get that alpha over 2 is equal to 0.025. So the area to the right is 0.025. And we can rewrite the critical value as z sub 0.025. So now we need to find the z-score that gives us an area to the right of 0.025. We can find this value using StatCrunch or Table 5. Now let's look at a second way to find alpha over 2. We want to find the critical value that corresponds to a 95% confidence interval. So that means we're looking at the middle 95%. We can rewrite 95% as 0.95. The area in the right tail is alpha over 2. And z alpha over 2 is the z-score that has an area of alpha over 2 to the right of it. Remember that the area under the curve is 1. So if we have 0.95 in the middle, that means that the area in the two tails is 0.05. However, we don't want the area in both tails, we want the area in the right tail only. The tails will have the same area, so if both of them together have an area of 0.05, this means that the area in one tail will be 0.025. So alpha over 2 is 0.025. And we can rewrite z alpha over 2 as z 0.025. So now we need to find the z-score that has an area to the right of 0.025. We can find the z-score by using StatCrunch or Table 5. Let's go to Stat, Calculators, Normal. And we want to find the z-score that has an area of 0.025 to the right. So because it's a z-score, we will have a mean of 0, a standard deviation of 1. We have the area to the right, so we will change this to greater than or equal to, and then we will remove this value. Remember that we have the area, so that means we need to put the area here so we can get the answer here. The area to the right is 0.025. Now let's press compute, and we get approximately 1.96. Rounding to 2 decimal places in StatCrunch, we get that z sub 0.025 is approximately 1.96. Now let's find this value using Table 5. Remember that Table 5 gives you the area to the left. So if the area in the right tail is 0.025, That means the area to the left of z of 0.025 is 1 minus 0.025. This is equal to 0.975. So now let's find 0.975 on table 5, and this corresponds to the row of 1.9 and the column of 0.06. And we also get 1.96.